Everybody's talking about making AI safe. It's the conversation of the decade. But what does that actually look like in the code? How do you build responsibility right into the machine from the ground up? Well, today, we are cracking open a really fascinating blueprint for exactly that. It's called the Elosia Model. This quote right here, it just nails the central problem, doesn't it? We can spin up an AI's capability and send it to millions of people in a blink. A model can go global in an instant. But responsibility? Well, that doesn't just copy-paste. And this massive gap between power and accountability, that's the challenge we're digging into. So, this forces the real question, right? How do we stop just talking about responsibility as a vague concept and start engineering it? Making it an inseparable, fundamental feature of the technology itself. To really see the solution here, we first have to get a crystal clear diagnosis of the problem. And Elosia has a name for it, the AI responsibility gap. Think about it like this for a second. Our current approach to AI safety is a lot like handing a Formula One driver a 300-page rulebook and just hoping for the best. The rules are totally external, they're reactive, and they rely completely on the driver to follow them. What if, instead, we engineered the brakes, the steering, and the safety systems directly into the car? See, that's the huge shift from policy to engineering. And that leads to their pretty radical proposal. Stop treating governance like some PDF or a Word document nobody reads. Instead, what if we started treating it as a fundamental operating system for intelligence itself? This slide just lays out that shift so perfectly. Over on the left, you've got the old model, the external reactive rulebook, and on the right, the new model, the embedded proactive brakes. It's literally the difference between investigating a crash after it already happened versus building a system where the rules are enforced in real time, right in the code, before a mistake is even possible. So their mission becomes super practical. It's all about building systems that are, first and foremost, observable, so we can actually see what the heck they're doing. Second, they have to be controllable, so we can step in and pull the plug if we need to. And third, they have to be aligned, so they're actually working towards our goals. All of a sudden, these big abstract ideas like accountability and transparency stop being buzzwords and become concrete features you can actually build. So how does this actually work in practice? Let's peel back the first layer of their whole ecosystem, the Elosia Research Lab. You can think of this as the architectural blueprint for everything else. Now, this is a really, really critical point. The research lab is not software you just download and run. Think of it more like a library full of architectural plans, a registry of proven ideas. It's published specifically for study, so developers and researchers can learn the principles of building these governed systems from the ground up. And when you look inside this blueprint, you see just how deep it goes. You start with the foundations. These are the core principles, like designing systems to fail safely, not fail open. Then you have patterns. These are like reusable design templates for critical parts with safety already baked in. And the system atlas maps it all out, showing how all these governed modules connect. So it's not just a list of parts, it's a really comprehensive, logical guide for building AI you can actually trust. Let's make this totally concrete with one of those patterns. What in the world is governed memory? Well, imagine an AI where its memory isn't just this chaotic, endless hard drive. Instead, its memory is engineered with a built-in constitution, rules that define how it learns, what it prioritizes, what it forgets, and even how it questions new information. You're literally embedding a sense of governance into the AI's core ability to remember and to reason. Okay, so we've got the blueprint from the research lab. But how did these architectural plans become actual tools a developer can get their hands on and use? That's where the governed store comes in. And this immediately brings up a huge question. I'm sure you're thinking it. If this is all about safety, why on earth isn't it just free and open source for everybody? It's a crucial question, and honestly, the answer gets to the very core of Elosia's entire philosophy. It's because in this model, adoption is an act of responsibility. That's the key insight. Unlike open source, where you can just copy-paste code with no strings attached, every single component from the governed store carries its context and its obligations with it. I mean, these aren't just little snippets of code. They're tools that shape an AI's memory and its authority to act in the world. So the access is deliberately structured. The price isn't about profit. It's a mechanism for traceability. It's like a formal handshake, an acknowledgement of the weight of the responsibility you're taking on. And here on this slide, you can see what that looks like in practice. There are these kits for specific tasks, like the memory and compression kit to build that constitutional memory we were just talking about. But again, that fee, it isn't a software sale. It's the entry point to a whole licensing process that creates a clear, auditable chain of responsibility, tying the tool directly to the team that adopts it. The process itself is designed to make you pause and think. As you can see, step 1 isn't buy now, it's review. You're forced to acknowledge this is a governed license, not just another product off the shelf. Then you have to confirm the terms, accepting the restrictions and your own liability. Every single click is a deliberate act of taking on responsibility. It's designed to filter for intent. So let's just pull back for a second. What's the long-term implication of this entire approach? I mean, what kind of future is it trying to build for AI control? This quote frames the goal perfectly. This is not about restricting innovation or trying to slow down progress. It's about building the necessary guardrails that actually make it safe to accelerate. It goes back to our car analogy. Better brakes don't stop you from driving. They give you the confidence to go faster, safely. And that right there is the fundamental takeaway. This entire model represents a massive shift in when we think about responsibility, moving it from some post-deployment policy document to a pre-execution engineering requirement. It's all about building the brakes into the car from day one, not just handing the driver a rule book and hoping for the best. Which leaves us with a final and pretty unavoidable question. As these AI systems become exponentially more powerful and more autonomous, is this kind of engineered, built-in responsibility just a good idea, or is it the only survivable path forward? That's a question we're all going to have to answer, and probably pretty soon.